Hello friends, I am Vishnudas, an electrical and electronics student from GPTC Kalamassery. Today I am taking a presentation in the subject Renewable Energy Source. The topic is Tidal Power, and this topic is taken from the first module of the subject Renewable Energy Sources. Tidal power, also called tidal energy. It's a form of hydropower that exploits the movement of water caused by tidal currents or the rise and fall in sea levels due to the tides. Although not yet widely used, tidal power has potential for future electricity generation and is more predictable than wind energy and solar power. Basic principle of tidal power. A dam is constructed in such a way that a basin gets separated from the sea and difference in the water level is obtained between the basin and sea. The constructed basin is filled during high tide and emptied during low tide, passing through the sluices and turbine respectively. The potential energy of water is stored in the basin is used to drive the turbine, which in turn generates acids directly coupled to an alternator. During high tides. During high tide, when the level of water in the sea is high, seawater flows into the reservoir of the barrage and turns the turbine. The turbines then turn the generator shaft to produce electricity. In this layout, we can see that the water level of sea is higher than the reservoir, so the sea water flows into the reservoir. The flow of water rotates the turbine. Then the turbine rotates the generator and electricity is produced. During low tides, the seawater stored in the barrage reservoir is allowed to flow out into the sea. This flowing water also turns the turbines and generates electricity. Thus, as the seawater flows in and out of the tidal barrage during high and low tides, the turbines rotate continuously to generate electricity. In this layout, we can say that the water level of reservoir is higher than the sea level. So the water from the reservoir flows out to the sea and the turbine rotates and it produces electricity. Single basin tidal energy system. Powerhouse is situated at the mouth of single basin. Hydraulic turbine only operates during discharge of water from basin during ebb tide. During high tidal, basin is again filled. Power generation is intermittent. It cannot meet peak power demands. Double basin tidal energy system. System has two basins at two different levels and sluice gates are provided in the dam. Upper basin is filled during high tide and lower basin is emptied during low tide. Therefore, it creates a permanent head-off for turbine to operate continuously. Power generation is continuous. The peak power demands can be met by pumping water by other means from lower basin to upper basin. This is the block diagram of tidal power system. The flow of water rotates the turbine and the turbine is connected with a gearbox. And it is also attached with the alternator of generator, and the alternator rotates and the electricity is produced. There is a controller. It controls the production of electricity and also gives maximum efficiency. Wave energy calculation. The equation for energy P is equal to eta rho A into V cube divided by 2. Here, rho is the density of water and A is the sweep area of the turbine and V is the velocity of flow and P is the power generated in watts and eta is the efficiency of the turbine. Wave power calculation. The equation of P is equal to h square into T divided by 2. Here, h is the significant wave height and T is the average time between upward movements across mean, and P is the power in kilowatt per meter of wave crest length. For example, h is equal to 3 meter and t is equal to 10 seconds, and p power is equal to h square into t divided by 2 and is equal to 3 square into 10 divided by 2, that is equal to 45 kilowatt per meter.